Greetings. Thank you for joining today's webinar, Cloud Security Simplified. My name is Rochelle Wheeler, and I am joined today by Mike Bumba. Before we begin, I'd like to cover a few housekeeping items. There is a questions panel located in the lower portion of your screen. You may need to expand that panel by either clicking the plus sign or the down arrow to see the full view. We will take questions at the end of this presentation, but you are encouraged to submit those questions via the questions panel at any time. Today's session is being recorded, and the recording will be made available at its conclusion. I will now hand today's presentation over to Mike. Mike?
Okay. So good morning, all. Thank you so much for taking some time to sit with me through a short discussion on cloud security, how to enable cloud security, and how to do it in the most effective and efficient way possible. We're going to talk about what's necessary to secure applications in the cloud. We're going to talk about architectures, which you may have seen before, related to Azure in particular, common security architectures in Azure. I'll talk a little bit about what the features and functionalities, what you get out of the components in those architectures. And then I'm going to show you how you can achieve the same outcomes with deployments that have less technology, less cost, less complexity associated with them. So why? There's very good reasons why. And I think you're seeing all of this now. I just had a notification this week that another credit bureau, another agency that had information related to all the credit bureau accounts got hacked. So now I've gone through personally to all the bureaus and put a freeze on all reporting on my credit scores, just because it's getting to be a world where it is extremely dangerous. These hacks cost companies a very large amount of money when they happen. And I've had cases where these hacks have actually cost companies the company. They weren't able to be solvent afterwards, weren't able to do business afterwards. So generally speaking, when you look at security, you can do a physical security analogy for most things that happen in the cyber world. Firewalls, they act like a door. They let something through to your network. But just as a door, they don't really understand what they're letting through that well, right? They can be intelligent firewalls, but they're still not going to really know what's happening outside of that very edge of the door, right at the lock mechanism. But there's technology now that you can put on the network that allows you to see broader across the network. You see the flow activity in the network and hacks that are ongoing in real time. That's why the second door over here, we see a Ring doorbell camera. The real goal is just simply to show you there's a way now you can take the technology that you've been using and enhance it to be able to make a better decision on what you're allowing into your networks. I've got a couple of slides in here, which are from the IBM Data Breach Report, Cost of a Data Breach Report 2024. So this is current data. That report is available at the link that you see on this slide. I think that if you are interested in security, you probably should take the time to write that link down. It is a great report. It's not vendor specific, so it'll talk to you a lot about the things that are happening, the cost, the general classes of technology that'll help you better manage risk and reduce the amount of damage that would happen when a compromise does happen. And in the world of cybersecurity, there's really only two states: those people that have been compromised and those that will be compromised. There's never going to be those that won't be compromised. So if you think that's true, you need to get out of that mindset, because that's what happens to all these big companies with massive investments in cyber, and they still end up on that list of those that have been compromised. So I didn't really mean to scare the hell out of you, honestly. My goal was simply to go ahead and set the stage, letting you know that the world of cybersecurity is extremely important. You probably wouldn't be in this webinar if you didn't know that already. And then some general requirements that exist in the cloud security space. So if you are interested in this, if you're a professional in security, you'd want to reach out and touch, the U.S. government resources. The Cloud Security Technical Reference Architecture is a great document. The FedRAMP checklist or the FedRAMP documentation are also great documents to look at. These things define the requirements for security. And I'd recommend that you look at them closely to see what it is that the government believes, that technical professionals in this space believe is appropriate for securing environments. From these documents, though, you can infer complicated, fairly complicated diagrams that say this is what they're asking me to do. You know, if you look at this diagram, we've got, this is an Azure-specific diagram. So we've got connections into Azure from the public cloud. Those connections go through network security groups, and then they go into firewalls. The firewalls output to application load balancers, which then spread traffic to the web tier traffic, and then which would go through additional load balancers to get the business tier and the database tier, or whatever the back end for that front end application server is. So this architecture, when you deploy one of these things, each one of those little diagrams, each one of those squares, triangles, rectangles you see in this diagram are all services that you would have to acquire from Azure. So as you can see, there's quite a bit of boxes in here, and all customers typically want to do when they start their cloud journey is, I want to put an app in the cloud, I want to secure that app, and I want to begin using it. And all of this is great for large-scale data center migrations into Azure, but if you're trying to get started, this is a lot of overkill. But if we take that drawing and we expose out just a piece of it, and we're looking at right now just the firewall, the first set of load balancers, what does that path really look like in more detail? This is what it shows. So again, network security groups, what does a firewall do, first off? In Azure, you're not going to be terminating your TLS connections. Your web connections aren't going to terminate on the firewall. It's really unusual to see that. What's more likely to happen is that firewall is going to act as a device that limits access to certain IP addresses and certain protocols. And it can do it based upon more than one Azure subnet. So you can have multiple Azure subnets, and you can have then access limited to those subnets based upon ports and protocols. What does a network security group do in Azure? A network security group limits access to certain either subnets or network interfaces, those NICs, based upon IP address or port or protocol. So the NSG, from a perspective of basic firewall functionality, does the same thing that a dedicated firewall does. So if you're looking for what are my requirements, right? The first thing you need to do on any security architecture is limit access into your environment. And that's what these access control lists do. But doing them at two places, it seems like a little bit of overkill. It's not really critical because you can set the ports and protocols for allowed access, especially for management related traffic, right? You can say only these source IP addresses can gain access to the backend systems for management. And you can do that all within the network security group and don't need to spend the money or implement the complexity of a dedicated firewall to do that. You'll notice also the blue diamonds in here are Azure load balancers, and then the gold ones are a product from Progress. That's called LoadMaster. The LoadMasters are enterprise grade load balancers, which means that they can do all of those things you see in this little red box above that gold triangle. You know, pre-authentication, application proxy, authentication proxy, TLS enforcement, you know, encryption standards enforcement, web application firewall, intrusion prevention, DDoS mitigation. They can do rate shaping and QoS controls, credential translation, which they can do, which, for example, let's say you have the need to support certificate-based access. And a lot of folks in the US government do have that requirement, support certificate-based access, whether it's called a PIV card or a CAT card. Behind the scenes, under the cover, it is certificate-based access. And we can translate that to a method that the servers understand how to support. Health checks, load balancing, and then the ability to export flow data. And that is really critical, and we'll talk to you a little bit more about that in the coming slides. So now let's look at this architecture simplified. So what do you really need to go ahead and make all of this work? So again, we talked about you need an access control list. You need a way to limit inbound activity. But let's say you're going to limit inbound activity to just web-based traffic. So you're going to allow inbound activity to the web servers. But within that activity stream, people can do bad things. And that's typically what we're seeing, right? We're seeing SQL injection attacks, you know, cross-site scripting, request forgery. You're seeing attacks that are been out in the world for a long time, being used to continuously compromise web services. So how do you stop that? Well, you use an application-specific firewall. In this case, because these are web applications, you use a web application firewall. And that web application firewall functionality is built right into the load balancer, into this product we have called LoadMaster. So now you've got the ability to access control lists, control what ports and protocols are coming into your network, and you're able to watch that traffic that is allowed to make sure somebody's not trying to use it to hack the backend web servers. So you've met the core requirements of, limiting access and ensuring that that access that is being used appropriately to get to the backend web servers. So in this architecture, we don't see any Azure load balancers that are not required, because you can assign a public IP address right to the load master. This architecture does include a little bit more resilience than you might have to have. I mean, in honesty, if you took the top load balancer and the backend web server and that's all you put in place, you would have the functionality to protect one backend web server. If you have a farm of backend web servers, then you're looking for high availability and the ability to properly schedule traffic across those backend web servers so that they don't get overloaded. And to do that, we recommend a pair of load balancers. When you extend this geographically, let's say you're going to do this exact thing in 2 different Azure regions, then you need a way to decide where does traffic go to region 1 or region 2, east or west or central, or wherever it needs to go. And to do that, you need a third service, and that's what this geo load balancer down at the bottom does. Its intent is to make sure that when a request for a host name is getting resolved to an IP address, that the IP address is the one that best satisfies that customer's request for access. So it'll get them either connected to the closest data center, or it'll get them connected to one of the load balancers that is up and available for use. If any of these load balancers are down for maintenance, the geo load balancing service knows. It's able to health check the service strings, and it knows then that IP address isn't available to use, and it won't pass it out. So, and basically this architecture is scalable. This little architecture right here can scale out to very, very large data centers, or you can do it in a small environment. There's one more item that's in here or a couple more that I haven't talked about. One's called a flow collector and the other one's called a jump box. As you start your journey to get more secure, what you're going to want to do is take that network security group and limit management access. You're not going to want to let management come in through the load balancer straight to the backend application servers, or straight to the backend application servers. You're going to want to make sure that the traffic is for management's contained within that virtual data, that cloud data center. Well, to do that, use a jump box, right? So in this case, it's a jump box that I recommended a Windows one, because we can do remote desktop protocol, RDP load balancing on the load balancer. So accessing the jump box is actually still through the load balancer. So it's still going to have a network security group in front. You're going to specify these IPs or these IP address ranges are allowed to access that jump box. It'll go through the load balancer, and then it'll go to the jump box. And the jump box then can manage those things that are inside of the cloud, behind this security perimeter. The flow collector is for dealing with, if you remember my analogy about front doors and the Ring camera, well, this is the Ring camera for your network. So what this collects is flow data. The load balancers can be flow data sources. Flow data is often difficult to get out of cloud environments. Well, in this case, the load balancer itself generates flow data and will send it to the flow collector. So you'll get IP fix, rich flow data, which is similar to call record accounting for your cell phone. Who called who about what for how long? And you can use that data then to see, are there patterns in the data that reflect somebody's trying to crack my passwords? Are there patterns in the data that reflect somebody's trying to exfiltrate my data? Are there patterns in the data that when you put them together indicates that there's ransomware running and somebody's trying to do something bad in my network? So we'll talk about that a little bit later as well. So now we're going to jump over to a demo on this. So first off, what does the load balancer look like? Well, here's the load balancer's front-end IP address. When you connect to it, you're going to sign into an appliance. This appliance is on a temporary license, but We offer pay-as-you-go licenses in the cloud, and we offer permanent licenses as well. For very large-scale customers, we offer the ability to scale up and down the number of devices that you have based upon your demand. So you don't have to continuously come back to us and purchase additional licenses. So we have multiple ways to consume the product, but the product is, for all practical purposes, a virtual machine sitting in Azure, whose purpose in life is to let users connect to it, and it connects to the back-end application servers, and it protects the back-end application servers. So I've got one virtual service set up on this one for one back-end web service. In this case, it's going to be an Apache web server. The key within this is there is a function set within this appliance. It's called Web Application Firewall. In Web Application Firewall, when you enable it, now the WAF is being used to watch the traffic being sent to those backend servers. Now, there's a series of rules and policies and procedures that are all being checked inside of this Web Application Firewall. By default, when you turn it on, all those things in blue are already checked. And what does that do for you? Well, if you are using the web server appropriately, if you're going to that web server, using that web server's name, then it should connect all the time, unless there's a problem with how that web server uses certain types of traffic. And then you can tune the WAF to deal with that. But as an example, here we've got the Apache web server being connected to by its host name. The WAF right now is turned off. There are security professionals who will tell you never let somebody connect to your website using an IP address only, because that lets them scan your entire domain based on IP addresses and figure out what you've got and where it is, and that's not necessarily a good idea. So there are, one of the standard rules in the WAF is to go ahead and not allow connections if the host header, if the IP address is being used to try to connect to the server. Well, right now the WAF is turned off, and as you can see, I can still connect to that service. The next thing is when you look at SQL injection attacks often have something that looks similar to, or other constructs similar to this inside of the request string. So I've got a simulation for a SQL injection attack right now because the WAF is off. It still lets me connect to it. So I can do these things and show it. And then, of course, we can look at, this is an example of what a remote code execution check would be. There's a lot of checks, but this is a real simple one. Again, all this lets me access this device. Well, that's not ideal, right? You don't want all this stuff to come into your machine. So what you can do is you can go into the Web Application Firewall, and you can go ahead and enable the Web Application Firewall. Now, the Web Application Firewall, in this case, it works based upon rules. The rules all have a score and number attached to them. The numbers get all added up every time the rule triggers, and if a request going through the load balancer exceeds that total score, then it blocks the attack. Well, I've set the anomaly threshold to 5. I'm going to go ahead and move this down just a little bit to start off with, and I'm going to show you what I've got. The web application firewall is now turned on. Checkbox is there. Can I still get to it using a host name? Yes, I can. Can I get to it using an IP address? Yes, I can. Let's go and do that same exact thing again and move that threshold down to 1. Course. Okay, access denied. Should be getting access denied here as well. I'm not sure why I'm not. But this is an example of, again, the SQL injection attack showing access denied. This is an example of cross-site scripting showing access denied. And then I think what's happening over here is I must have a rule set. Yep, unchecked related to host IP addresses. I'll re-enable that rule. Go back over here, check again. Sorry, I need to set it. And I get access denied. So all of these rules, whether it's an IP address block request, or it's related to SQL injection type pattern, that recognition and blocking, or it's related to remote code execution pattern and blocking, it's actually all the OS top 10 attack vectors are managed and mitigated through the use of the Web Application Firewall. The Web Application Firewall also has an easy way for you to look at this. For example, let's say this IP address connect is required. I have an application that calls this server in the cloud, so I must have it turned on. Well, we have an easy way within the load balancer to see what rules are being triggered and to go down and find the rule related to IP address restrictions and to simply disable that one rule. So here we have host header as the numeric IP address. I want to go and turn that one thing off. And let's go and take a look over here again and refresh this. And I'm now able to connect to the website. So this is quick and dirty. The web application firewall is intended to provide that additional layer of defense that has to do with you've allowed traffic into your network. Now you want to make sure the traffic is being used appropriately. So again, one platform to manage that provides app gateway, load balancing, meaning that the Progress Loadmaster is one platform that you can use to manage app gateway, load balancing, web application firewall. We also do content modification, URL steering, credential translation, and global load balancing. So same exact product can do all of these different things. In the world of URL steering, in the public space, those elastic IP addresses cost money. You would like, if possible, to put as many sites as possible behind a single IP address. And that's what the Loadmaster lets you do. It says, okay, I see this request coming in. I'm looking in the header field. I see it's going to this host name. So I'm going to direct traffic to the set of servers associated with that specific URL, that specific fully qualified domain name path request. And it keeps your cost down related to elastic IP usage. Why do this? Well, you saw the first diagram and the second one. They're both relatively complex, lots of Azure components, lots of other components in there. And it's expensive pretty fast when you try to build out a full Azure architecture, standard reference data center approach. But if you look at the functionality, what does each component do? What is the feature that it provides me? This thing provides me an access control list that blocks all inbound requests except from the ones I'm let it use, to the things I'm letting it connect to. That's what a network security group does. It's also what a firewall does. If you have a lot of subnets, if you have a very complex backend inside of the cloud service, it may still benefit you to use a firewall to do that access control list management. But if you're starting in this area, you've got a relatively simple deployment within the cloud, there's really no need for that. You can just use a network security group and an application firewall like a Loadmaster to provide proper security. So what is Loadmaster? Well, it's been around for 20 years. The company's U.S. based. It's been certified for use in the highest systems inside of our U.S. government. So NIPR, CIPR, JWICS, which is basically unclassified, secret, and top secret networks. We sit on all of those. We're across all commercial organizations. Non-defense organizations in the U.S. government. And we've got very, very good reviews. So the product, the Peer Insights is basically peer review. So the people who operate the technology score the technology, and we're the highest rated application load balancer in that market. And the other two rating services as well, you've probably heard of them both, and we get extremely good reviews out of these. Now we're going to switch gears a little bit and talk about the second half of this. So we've talked about how do you defend, and then the thing is how do you detect, right? So defending is the firewalls and the load balancers and the web application firewall services. But detection now is something different, and you can detect lots of different ways. You've probably got some technology on your endpoints right now, which help you with detection. You may have put some packet capture gear in at certain network edges to try to figure out what's happening on your network. I'm here to tell you that the ability to see across your entire network is really important for detection. If all you're doing is looking at one point and you're not looking across the entire network, you're going to miss something. And the something you're going to miss is going to be important, and it's going to end up hurting you. Gartner's comment is that detection and response are now more important than blocking and prevention. And their comment is based upon what they're seeing in the industry, right? They're seeing people investing heavily in defensive technologies and still getting compromised. And the compromise is taking a long amount of time to figure out they're there first, and then to be able to react to them and get it cleared up. So how do you do that? Well, we believe our technology set is based upon flow data, net flow data, IP fix, JFlow, SFlow. We believe that within that flow data is enough intelligence. You can determine enough with the proper technology to see what's happening on your network. And we've got a lot of good results with that approach. That approach allows you to use collectors to collect flow data from your existing devices, like routers generate flow data, as well as putting in probes to generate very rich flow data close to your application sources. And the combinations of the two give you a really good view of what's happening across your network. So with network detection response, which is one of the services you can get out of out of our flow collector, which is called Flowmon, you can see quickly a data breach is happening. And when we have our pilots running within the first 30 minutes, organizations are starting to see traffic that looks suspicious. We typically do a tuning session with them within the first day to make sure that the setup was set up properly. And after that, the data they've got in there is highly reliable. So our goal is to minimize false positives, give you actionable intelligence, and basically letting you get ahead of the damage that's being caused by a breach. So the breach is going to happen. Just plain expect it to happen. No matter whose technology you've got, that breach is going to happen. The question is, how fast can you detect it? How fast can you respond to it? So what makes us a little different? Well, we've got a lot of intelligence built into our platform. People call, I don't want to, this AI space, ML space, I prefer to use machine learning because that's what the device does. It learns about what's happening on the network as it watches the traffic transiting the network, determine what's normal and what's not. It can do adaptive baselining, which means when users' behavior or devices' behaviors change and volumetrically, when somebody's trying to copy a lot of data in, a lot of data out, we can see it, we can alert on it, heuristics, behavioral patterns, reputational data. All this is like 40 detection methods and 200 individual algorithms, and its goal is to make sure that when we tell you something's bad, something's bad. So with this average cost, of around $5 million in breach, and the ability to reduce the time it takes to detect and react can end up saving you millions of dollars. So we're going to go into a demo now on Flowmon. So this is the Flowmon dashboard. When people first sign on to Flowmon, what they're going to see is an overall view of, this is in this particular case, the SecOps, the security operations in their network. And what we're seeing in the security operations view is we have ransomware attacks being detected by the product. And if we drill into this ransomware attacks, if I clicked into this, what I would get next would be the dashboard for ransomware attacks, which looks like this. And we can pull into here and we can say, okay, what's actually happening? Well, let me go and do this thing, Matt, actually physically for you. Click here. It takes a little bit of time to spin these windows up. That's why I was clicking straight through to them with tabs that were already opened up. I'm going to give you the freshest view. What is a ransomware attack? Well, it's a series of attacks, which when you put them together equal ransomware. Well, what are we seeing inside of Flowmon? We're seeing ICMP anomalies, which means somebody's using the ICMP protocol, which is a management protocol within the network, for something other than management. We're seeing dictionary attacks. We're seeing the patterns associated with somebody trying to crack a password by simply throwing multiple attacks at that machine using different passwords. We're seeing scans. In this case, we're seeing a scan from a device who is a workstation. It is not a server. It is not part of your network security architecture. It is a common user's machine, and now it's trying to find out who's around it and if those devices around it have vulnerabilities. It's beginning to try to upload data, and it's beginning to connect to blacklisted servers. We maintain and update continuously a list of all IP addresses for all known botnet controls and botnet networks. So when we see traffic to those, we know that activity is bad. There's no question about it because we know those are bad systems. Another dictionary attack-based system for attacking systems. So all of this stuff together indicates to us that we have actually just that one connection to a blacklist would let us know immediately. That's a commonly used control network for ransomware. We can go and affiliate that, but putting them together, you can see that you have ransomware. Now, the next question, of course, is if I've got all this bad activity, where's it coming from? And if you look into any one of these, what you'll see real quickly is the source IP address, the thing inside of your network that's causing this problem inside your network is this 192.168.1.50. We can enable automation to block that device. Now, we're not a blocking technology, right? So we can, on an alert, on an event, we can run a script. That script could go ahead and pull information from the event, send it to a device like a firewall, and you could go ahead and block that IP address. You could also take it all the way down to the switch level. You could turn the port off the switch for that user if they're inside your network, right? If they're in one of your data centers. And then you could go ahead and mitigate that risk while you're working to figure out exactly what's happened. But again, if we say one event, okay, to 50, is that really important or not? But if we take another look, we'll see we have a second event associated with IP address 50. We have a third event associated with IP address 50. We have yet a fourth event associated with IP address 50. When you add these things up, I mean, it's very simple to realize this machine's got a problem, and the problem is severe. Let's get it off of our network right now. This ability to detect happens very fast. It's easily within a 30-minute window. It typically takes someplace around 5 minutes to 10 minutes to begin to see these attacks starting to stack up as the device is doing different things. And if your security team is watching this, we can send alerts and alarms based upon what you see in here as well. So it doesn't have to watch the console to get this information. We can send pager alerts. We can send SMS messages. We can go ahead and send email messages. We can work it into common chat-based mechanisms like Splunk. Like Microsoft Teams. So you can get these data flows, these event flows showing up in real time to people, and they can then take action on them. So that was a quick one on Flowmon. I want to touch one more point real quickly. Flowmon is more than just network security operations. Flowmon watches the network itself. It'll tell you how well the network is working. It watches applications. It'll tell you how well applications are working. If you put the probes in close to your servers where TLS connections and activity take place, you can watch for TLS activity on your network and the kinds of things you can see, for example, in TLS. How many of you have had the problem where your website's certificate expired and your customer can't access it because somebody didn't catch it fast enough, right? So we can actually see certificates that are in expiring, TLS expired certificates. So all of this is available inside of a single platform. So this one device called Flowmon Collector, which is collecting all the flow data from across your network, and analyzing that data can tell you what's happening from a security perspective, from a application perspective, and from a network perspective, or the retransmits on the network because my network ingested at certain points. It can even go deeper than that. It can look at transactions between components in your architecture. It can say there's a SQL query that's taking too long to respond. I can watch SQL. And in watching SQL, I can tell you that there are queries that are taking more than a few milliseconds to respond. Our example on this system has queries that are taking 1 or 2 seconds or longer to respond. And then you can look into the query and you can say what exactly in that query. Perhaps a scope is too large. Perhaps one server out of your cluster of SQL servers, if you have a backend cluster, is performing poorly. And it lets your application people quickly drill in and solve a problem. So the whole goal with Flowmon is visibility and enabling you to respond quickly so that your customers are always satisfied with the services you deliver. Okay, so back to presentation. One platform to see across your entire network with the ability to automate the detection and response process. And according to the IBM Cost of Data Breach Survey, and they were very conservative in this average savings per major security event of 1.88 million is way below the cost of the system, way below. I mean, we're talking 10 times more loss than you would actually spend putting these systems in environments. So the goal is you want to be able to see what's happening in your network so that you can respond quickly when bad things happen, whatever that bad thing is. And that's what Flowmon will allow you to do. Again, Flowmon's really well recognized in the industry. All of these organizations have us listed. So EMA, they've got us up in the leadership quadrant. Forrester, they've got a report on network traffic analysis and visibility, and we're listed in that report. The quadrants and Gartner. All of these folks are hot on the technology in general, meaning the ability to detect and then quickly react based upon flow data, which is much more scalable and much lower cost than trying to accomplish the same thing using packet data. That's why we took the flow approach. Storing flow data is about 500 times less dense than packet data is. So for every 500 bytes of packet data, you collect 1 byte of flow data. That means your storage requirements are much smaller. Your time to analyze it takes a lot less time because you're going through less data, but you can still find, using the algorithms we've got, the information that you need to operate your network. So at this point, I'm going to stop and ask for questions.
So, Mike, I see we have a few questions in the questions panel. The first that we have is, if the Azure NSG and the Azure Firewall are doing roughly the same thing, do you really need an Azure Firewall?
My comment, I think, would be that when you take the NSG and the application firewall, the web application firewall functionality together, that you get when you add a Loadmaster or similar product with a robust web application firewall and the NSG, then you achieve the same value. So but when you're talking about very large, complicated cloud architectures where they've got a lot of different VLANs, a lot of different, VNets, and they want to do, then having a single console, a graphical interface to be able to manage those access control lists, which a firewall can give you, is of benefit to you. So it depends. I would say that for small, medium deployments within the cloud, it's not a critical component. You get the same value out of an NSG and a WAF, web application firewall. If it gets big enough, then you're probably going to want to see it because it's going to be a little bit more difficult to manage the NSG using just the native tools that are available inside of Azure than it would be to manage access control lists on a enterprise class firewall.
Perfect. I have a second question here. So the second question is, I have a packet capture installed at my data center, and it provides good visibility. Why do I need something else?
That's actually a really good question because, the industry for the last, 25 years has focused on packet capture. So there's a lot of technology out there, a lot of manufacturers that have been selling this for a long time. The focus in flow collection, although flow's been around every bit as long. NetFlow was defined almost at the infancy of the internet. How do you collect information about what your routers are doing? So it's been around forever, but the use of that flow data in a robust manner hasn't really been out that long. We've been doing this for around 10 years. The industry at large has been doing it for about the same amount of time. So professionals that have grown up with packet capture, they don't know often, or they don't really think there's value in collecting data from other than the location the packet capture device collects at. So that packet capture device is going to collect at a core switch in your data center or off of a tap on the line that leads to your egress firewall or your egress router. And it's going to tell you very good information about what it can see. And it can see just the traffic going into and out of your data center. If you put another one in your building for you have a large number of customers, you can begin to see everything that leaves your building, that's customer traffic, your PCs, your users, and goes into your building for PCs and users. What you can't see, because most people don't have the budget to do it, is putting packet capture in on all of your subnets. If you put packet capture in on all of your subnets, it would absolutely destroy your bank account. And it would create so much data and so much alerting information that you'd be overwhelmed by it. You wouldn't be able to deal with that volume of traffic. What we can do is we can collect all the way down at the subnet level flow data. We can see when Steve's machine is scanning in its own subnet and trying to compromise, Sharon and Bill's machine, and we can see it in near real time within a minute of the activity starting. We can see that scanning activity starting, and that's unusual activity. We'll alert you on it. We'll let you know when somebody walks in from Starbucks, and they've gone to Starbucks and they plugged into their network and somehow they got ransomware on their machine. And now they've connected to your corporate network via VPN if they're coming from home, or inside your network, plugging into a network port. And it begins to try to find other devices around to compromise. Because one of the biggest challenges with ransomware is not cleaning it up the first time. It's making sure you got it all. Because what that software does, it goes and finds everybody else it can put that software packet on, and it puts timers on those packets. And sometimes they're random, and it doesn't always run. It's not like an always on attack service. It sits there and it waits. And once you've cleaned up your first compromise and you've paid the Bitcoin, you've got your data back, and you've spent that, $2, $3, $4, or $5 million in recovery, it happens again. And this time it's not because somebody brought something in, it's because something was left behind inside your network that you weren't able to see. But how much powerful is it? How powerful is it to know when that other device wakes up and then starts scanning, it starts its activity related to ransomware. As soon as it starts its activity, you see it immediately. And then you can script immediate responses to it and block that device off the network. Or if you're not that aggressive, or you don't want to have that potential for, blocking traffic inappropriately, you'll at least alert your security team in near real time, and they can go out, they can take that machine off the network, they can check it themselves. But you can get ahead of the problem so that now all your data is not re-encrypted, all your data is not inaccessible anymore. So the goal, nothing is ever perfect, right? We can't tell you that if you use this technology, you won't get impacted by ransomware. Nobody in the world can tell you that. What we can tell you is we will let you know much, much faster than what you have today. Within minutes to hours, we will let you know that activity is going on in your network, and give you the opportunity to get ahead of it instead of that average of almost 300 days people are experiencing without this technology before they even know they've got a problem in their network.
Perfect. I have another question for you, Mike. This one comes from David. Can you show how to generate actions, Flowmon versus NAC Forescout solution? Do you have use cases?
Yes, we can go ahead. If David would like to reach out to us, if he could drop us an email, that'd be really useful, because what I can do is share with them some of the documentation on Flowmon, and I can also share with them some of the use cases where we've built these automated responses to common security services. Right. So we see something, and then we want it to tell something to react automatically to the device, to the event we've seen. We don't have it for everything, but we support the standard APIs for RESTful integration with other technologies. If that technology's got a REST API, then we'll go ahead and be able to connect to it. If we understand, or the customer understands how to program that device as using its REST API, then we can very easily work with that customer to create the appropriate response script that we go and touch that device and tell it to do something, whatever that something is. And it's pretty much code at that point. So that which I know people say that a lot, but it really does mean that you can do what you want to do within the limits of what that technology allows you to do. Because you can write code, which are scripts, to tell that device to do things via an API call to achieve a desired outcome.
Perfect. So David, I will share your information and this question with Mike, so you guys can take this further. So Mike, it looks like that is our final question for today. I'm trying to pause and give everyone a second, because oftentimes additional questions will trail in. But that looks like our final question for the day. I would like to thank everyone for attending today's webinar. And just want to remind you that you will receive an email containing the recording of this webinar. So feel free to share it with your peers. And if you have any additional questions, feel free to reach out.
Yeah. One last thing, Network Chuck did a series of videos. Loadmaster was one of those. If you watch Network Chuck stuff, you can find his information on Loadmaster. Loadmaster is licensed based upon how fast you want it to run. So we do have a free tier. So if you have a very small data center requirement, less than 25 megabits per second, the tech when you look at Azure in the marketplace, you're going to find there's a version there called free. And it is free. It just doesn't have support. You can't call us and ask us for help to make it work. But the thing is, if you are interested in this technology and you don't have a deep budget, you can practice with the stuff that doesn't cost anything. Flow on, we really can't do that with it. It's the technology doesn't lend us to the ability to generate a free tier. But we do offer, a proof of concept. So you can that either you can be self-paced and not have us help you with, or they can be paid for and we can help you get them set up, and then keep your cost really low to look at what that technology can do for you. So.
Perfect. I think that's the final question for the day.
Well, thank you all for spending time with us today.
Thanks all. Good day.